Hi everyone, and welcome to today's geology program. Who here can give me a definition of geology? Well, if we break down the word geology, we find that geo means the earth, and ology means the study of. So thus, if we put these two together, we find out that geology can be defined as the study of the earth. More importantly, the study of the earth's history. And that brings us to the question, who studies geology? Geologists study geology. Geologists are scientists who study geology. Who here thinks they might have at any point been a geologist? Well, I bet you'd be surprised to find out that most of you here have been a geologist at one point or another. Who here has ever had a rock collection? Who here has ever looked at a mountain and wondered how it was formed, a valley and wondered how it was formed, or any topography at all and appreciated it? Well, these are all questions and things that geologists do. And geologists, like most scientists, like to categorize things in order to better understand them. A great way to do this is to think of how rocks are formed. We're going to go over the three main rock categories and how they are formed. One of the main rock categories is sedimentary rock. Sedimentary rock is formed by layer upon layer upon layer upon layer of rock and sediment. Rock and sediment that have broken down and layered upon one another and left to the hands of time form sedimentary rock. Oftentimes, sedimentary rocks are left over from past environments. An excellent example of this is limestone. Limestone is a rock that is left over from an ancient ocean, so the shells and organic material have deposited upon one another, forming limestone. Another great category of rock is igneous rock. Igneous rock is rock that was once liquid molten rock that is now frozen in place. You can remember it easily by these motions. Liquid, molten rock that freezes in place. So it's ancient liquid rock that is frozen in place. It can be formed in two main ways. One way is intrusively. That is, the rock was molten magma that cooled directly inside the Earth's crust. Another type of rock would be extrusive. Extrusive is molten liquid rock that oozed to the surface of the Earth's crust and cooled directly on the surface of the Earth. An excellent example of this would be lava rock. And an excellent example of igneous rock is granite. Granite is a rock that is formed by three main minerals. One of these minerals is feldspar, the other is quartz, and the other being mica. It's one of the most commonly found igneous rocks. Another type of rock that we have, and another category of rock, is called metamorphic rock. When you hear the word metamorphosize, what comes to mind? To me, a caterpillar would come to mind. A caterpillar metamorphosizes or changes its form. So it starts out as a caterpillar and then metamorphosizes into a butterfly. A metamorphic rock is a rock that has changed its form. So it starts out as either an igneous or a sedimentary rock or another type of rock and changes its form into a metamorphic rock. This change occurs by heat and pressure. An excellent example of the way to remember this is to rub your hands together. When you rub your hands together, you create heat, and also if you push them together, you're forming pressure too. So this changes the chemical and physical makeup of the rock. An excellent example of this is schist. Schist is a rock that has been folded and molded so that it has swirls and folds in the rock, and where these folds and swirls occur, different rock has formed. Alright, an excellent way to reinforce this is to play a game called Rockety Rock. Rockety Rock is a game that resembles Simon Says and deals with the three main types of rock and can be played with a large group of students. Let me ask you all a question. If you could pick a fruit, vegetable, or fruit item to represent the Earth and the Earth's crust, what would it be and why? Well, to me, an avocado is an excellent example of a food item that represents the Earth. It has a bumpy skin that is very thin compared to its goopy outer center, which can represent the mantle, and is formed with magma. At the center, you have a core and a hard pit, which can represent the Earth's inner and outer core. Alright, so who here thinks the Earth's crust is uniformed like an eggshell? Well, the Earth's crust is actually more like a cracked eggshell. So instead of one large smooth crust, it's actually broken up into smaller plates. And these plates actually move. This theory of plates and how they're broken up and the movement of them is called plate tectonics. So let's dive into plate tectonics and take a look at a few different types of ways that the Earth's plates move. One of the Earth's boundaries is called a transformation boundaries. And a transformation boundary, two plates slide past each other, much like two tables rubbing against each other. And if you've ever rubbed two tables against one another, you'll know that something happens when those two plates or two tables meet. And if you were to say that the two tables would rumble and move, you would be absolutely correct. So these two plates, when they move and slide past each other, oftentimes causes an earthquake. So when you hear of a transformation plate boundary, you can think of an earthquake. Another type of plate boundary is called a convergent plate boundary. There are two different types of convergent plate boundaries. One being a continental collision. So two continental plates come sliding and slamming into one another. When these two plates meet, they both crumple up. An excellent example of this on the Earth are the Himalayan mountains. What is now India used to be its own continent that was floating around in the ocean. And it came and it slammed up into what is now Asia. And at that boundary, the Himalayan mountains formed. Another type of convergent boundary is called a subducting plate boundary. So, you have an oceanic plate boundary. So you have an oceanic plate, and then you have a continental plate. The oceanic plate is denser and heavier than the continental plate, and thus subducts under the continental plate. And this zone of subduction is called a subducting plate boundary. Oftentimes uplift will happen here, and you'll get plateaus and/or mountain ranges. Another type of plate boundary is called a divergent plate boundary. A divergent plate boundary is when two plates actually separate and move away from one another. An excellent example of this on the Earth is the Mid-Atlantic Ridge, and here, new crust is formed. Alright, so now that you have learned all these different geology concepts, let me ask you a question. Do you think that geology affects life on Earth, and how? One way that geology affects life on Earth is because of elevation. Elevation can affect the Earth in many ways. As we all know, the higher you are in elevation, the cooler it tends to be. And the lower you are, the warmer the climate tends to be. So elevation, in turn, can and does affect climate. The other way it can affect life on Earth is by mountains blocking rainfall. Mountains can block rainfall, causing rainfall to fall on one side of the mountain, having a lush, dense forest, and on the other side of the mountain, having a dry desert. So this also affects the climate and the moisture and rainfall of the Earth. Another major way that life on Earth is affected by geology is erosion. Erosion is a process of breaking down and weathering of rocks. There are many different factors of erosion. One factor is water. Water can be found in the form of ice. Who here has ever put a soda can in the freezer and watched it expand? When you come to get the soda can, most of the time it will be exploded, and that is because the water actually expands when it freezes. Another way that, and in this way, the ice that gets in between the rock and freezes breaks down and weathers the rock. An excellent example of this are the arches in Arches National Park. All right. Another way that water can erode rock is by rivers. If you've ever been to the Grand Canyon or any valley that has a river, you'll notice that it has steep, narrow sides. This process is very eventful and forceful and forms a V-shaped valley. Ice, going back to ice, glaciers are a major force of erosion too. So, unlike rivers, they will actually form U-shaped valleys, digging out the soft earth and the soft rock, exposing the bedrock. An excellent example of this is Yosemite Valley. Yosemite Valley is a giant U-shaped valley formed by glaciers. Another form of erosion, factor of erosion, is wind. Wind can carry fine silt and sediment and deposit it elsewhere. Excellent examples of these are sand dunes. Chemical weathering also occurs as well. One of the ways that chemical weathering occurs on Earth is by acid rain. So, do you think that geology affects human life as well? If you said yes, you would be absolutely correct. Geology affects human life in many different ways. We get our energy from the Earth, and sometimes we get it from rock. Coal is a type of rock that is actually formed by plant material. So in turn, that ancient sun's energy is actually trapped in the rock, and we mine and use that rock for energy in daily use. Another way that we use geology in order to help humans out is by mining metals out of the earth as well. We need metals to build things and also for transportation as well. Not only does geology affect humans by material goods, but also by geographical isolation and protection from others as well. So in the past, geology has been extremely important, and in the future and present, it will continue to be extremely important to humans. Well, I hope you all have learned and enjoyed this program. And I hope that you take this home with you and see that geology affects all of us in all of our daily lives. Thanks, and have a great day.